Is there evidence that time doesn't exist? What if everything we know about time is wrong? Imagine if the past, present, and future weren't distinct moments ticking by, but rather an illusion, a mirage created by our minds to make sense of reality. Sounds like science fiction, right? But remarkably, scientists, philosophers, and researchers are suggesting that time as we perceive it might not exist at all. Today, we're diving deep into this enigma, asking, is there scientific evidence that time doesn't exist? Throughout history, our understanding of time has evolved. In ancient civilizations, time was a cycle, governed by the rising and setting of the sun or the change of seasons. But with the dawn of modern science, especially Einstein's theory of relativity, our view of time radically changed. Today, as we push deeper into quantum mechanics and theories about the universe, new ideas are emerging that may challenge the very existence of time. To understand why some argue that time doesn't exist, let's begin with philosophy. In the early 20th century, philosopher J.M. McTaggart introduced a bold idea: time itself might be an illusion. McTaggart's theory is based on two ways of viewing time, which he called the A series and B series. A series. This is the traditional view of time, where events are experienced in a sequence of past, present, and future. This is how we usually perceive time, as something that moves forward. B-series McTaggart's alternative view suggests that events simply exist without a present moment. In this view, all events exist simultaneously, without needing a present. Interesting fact. McTaggart's ideas have influenced many modern thinkers, leading to a debate on whether time is linear or cyclical. Some believe that time might loop or even be multidirectional. Interesting fact. Many Eastern philosophies, including Buddhism, consider time to be an illusion or a mental construct, with consciousness creating the experience of linear time. This parallels McTaggart's view that time may be nothing more than a byproduct of how we observe events. In this philosophical view, time might not have a true existence outside our minds. McTaggart argued that neither the A series nor the B series could accurately describe time, and thus, it might be an illusion. When we move from philosophy to physics, we encounter a revolutionary perspective: Einstein's theory of relativity. According to relativity, time is not absolute but relative, depending on the observer's speed and gravitational field. This gave rise to the idea of a block universe. In a block universe, time isn't linear. Instead, all moments exist simultaneously in a four-dimensional block. In this model, past, present, and future are equally real and coexist, but we experience them sequentially. This could mean that the passage of time is an illusion, a way for our minds to process changes in the universe. Einstein's relativity shows us that time can stretch or compress based on how fast you're moving or how close you are to a massive object. This phenomenon, known as time dilation, is why astronauts on the International Space Station age a tiny bit slower than people on Earth. Interesting fact. According to relativity, time dilation means that someone traveling near the speed of light would experience time much slower than people who remain stationary. This idea, illustrated in movies like Interstellar, is a real scientific possibility. Interesting fact. Because of time dilation, the now you're experiencing isn't universal. Your present moment could be someone else's past or future, depending on their position and movement in the universe. This challenges our conventional view of time's linear flow. Relativity implies that time may not pass in the way we think it does. In a block universe, everything exists together, and what we see as the present might simply be our subjective perception within this four-dimensional structure. Moving into the microscopic realm of quantum mechanics, we encounter even stranger implications for time. Some theories propose that time might emerge from quantum properties like entanglement, rather than existing independently. The Page-Wouters mechanism, for instance, suggests that time emerges from the entanglement between particles. According to this theory, if particles are unentangled, they experience the universe as timeless, frozen, and unchanging. In this view, time isn't an absolute dimension but an emergent property arising from the interaction between particles acting as clocks. So instead of thinking of time as a backdrop, this model proposes it's the result of interactions. Interesting fact: quantum entanglement experiments have shown that particles can affect each other instantaneously, regardless of distance, challenging our traditional view of time and space. Interesting fact. In certain quantum experiments, particles have been observed to rewind their state, demonstrating that at a fundamental level, time might be symmetric. This contrasts with our experience, where time only moves forward. Quantum theories like these challenge us to rethink time. If time is an emergent property rather than an inherent aspect of reality, then it may not exist as we traditionally understand it. Instead, it's a byproduct of quantum processes. Section 4. Thermodynamics and the arrow of time. While quantum mechanics suggests time symmetry, thermodynamics introduces an arrow of time, a directional flow based on the second law of thermodynamics. The second law states that entropy or disorder always increases in a closed system. This increase gives rise to a thermodynamic arrow of time that only moves forward. It's why we see events unfold in a particular order: ice melting, eggs scrambling, or objects breaking. Entropy creates irreversible processes, unlike in quantum systems, where time can theoretically be reversed. In our daily lives, entropy shapes our experience of time's one-way flow. Interesting fact: entropy is why you can remember the past but not the future. In a universe moving from low to high entropy, events become increasingly irreversible, giving a forward direction to time. Another interesting fact: the idea that entropy drives time's arrow also explains why we observe certain events in a specific order. For example, drinks don't spontaneously cool down and form ice cubes, but the reverse occurs naturally due to entropy. Entropy might not be time itself, but it certainly influences how we perceive it. This entropic arrow of time is one of the few universally consistent observations in physics that gives direction to time's flow. Section 5. Time symmetry in physics, laws and perceptions. Many fundamental laws of physics, such as gravity and electromagnetism, are time symmetric. This means they operate identically whether time is moving forward or backward. But there are exceptions. Most forces in physics don't have a time direction. For example, if you recorded a ball falling and played it in reverse, the motion would still be physically possible. However, the weak nuclear force, responsible for certain radioactive decays, breaks this symmetry and only acts in one time direction. In radioactive decay, a neutron decays into a proton, electron, and antineutrino, but the reverse doesn't naturally happen. This phenomenon is a rare example of time asymmetry at the subatomic level. Interesting fact: the weak force is one of the few known exceptions to time symmetry in physics, making it crucial to understanding time's directional flow. Another interesting fact: the structure of the universe, including the imbalance between matter and antimatter, suggests an asymmetry that might help explain why time appears to move forward. The concept of time symmetry forces us to confront the question: if most laws of physics don't require time to move in one direction, then does time itself even exist as a distinct flow? Section 6. Experimental approaches and future theories. Scientists are actively exploring these ideas, but testing them is challenging. In experiments, we typically rely on classical time, so proving or disproving the existence of time is exceptionally difficult. Studying time from a quantum or relativistic perspective requires immense precision, and many theories can't be tested with current technology. Experiments at CERN and the development of quantum computing may allow us to explore time more thoroughly, potentially leading to breakthroughs that challenge our current understanding. Interesting fact: some physicists believe a future theory that unifies quantum mechanics and relativity could eliminate time from the equations entirely. Another interesting fact: quantum computers, due to their unique ability to simulate quantum states and entanglement, might be able to probe questions about time in ways that classical computers cannot. Scientists believe these simulations could reveal new perspectives on whether time is an emergent phenomenon rather than a fundamental dimension. Despite all the advancements, experiments related to time are on the cutting edge of physics and technology, and the answers we seek may only come with even more advanced tools and theories. Conclusion: the future of time. As we've journeyed through theories and scientific discoveries, it's clear that time might not be as straightforward as it seems. From Einstein's block universe to the quantum perspective where time could be a byproduct of particle interactions, we see that our understanding of time is still evolving. The second law of thermodynamics offers a clear arrow of time, yet many fundamental physical laws don't require time to flow in any particular direction. Entropy, relativity, and quantum mechanics all hint that time might not be a fundamental aspect of reality, but rather something that emerges from other, deeper laws of physics. So, what if time doesn't exist in the way we think it does? What if the past, present, and future are merely constructs we've created to make sense of our lives? The implications are profound, as it challenges our understanding of life, death, and existence itself. If time is truly an illusion, how would that change our approach to life? Would we prioritize different moments or experiences if we knew they were all happening simultaneously? These are questions science is only beginning to grapple with, and your thoughts matter too. Let us know in the comments below what you think. Does time really exist, or is it just an illusion? And don't forget to like, subscribe, and stay tuned for more deep dives into the mysteries of our universe.